In this problem, they give you a graph, and whenever you have a graph, just make sure you pay attention to the units. So in this problem, they ask you, find the average acceleration during the time interval during t equals 30 seconds to t equals 40 seconds. Use two sig figs, and the units should be in m over s squared. So the first thing you can do is just break this problem down, and you have just write the formula, because it wants you to find average acceleration. So just write it. Acceleration equals change of velocity over change of time. You write that, and you have to remember that change just means final minus initial. So it's just final minus initial of velocity, final minus initial of time. So then you go to the rest of the problem, and you have t equals 30 seconds right here, t equals 40 seconds. So what you have to realize is that 40 is going to be the final, because you start at 30 and you end at 40. That means 40 will be the final, 30 will be initial. So then you go back to the problem, and you just plug in the numbers. So where I got these numbers from is v final. So v final, since I just said that 40 seconds will be final, the velocity at 40 seconds is actually 0. And for 30 seconds, you look at it, and you look at where it is, and it's at 60. So it'll actually be 60 for the initial velocity. And then the final time will be 40, and the initial time will be 30. So that's all I did. I just plugged in those numbers, and you'll get negative 60 over 10. And always make sure when you get an answer, write it in the right units, actually. So on the top is velocity, and that's where the graph comes into play. Right here is velocity, so it's going to be kilometers per hour. Because since this 30 was here on this line, it's going to be 60 what? Kilometers per hour. And here, since it's 30 what? 30 seconds. So that's all I did. So it's negative 60 kilometers per hour. Over here, it's both seconds, so it'll be seconds. So now what you're going to do is you go back to the problem. You have an answer. You go back to the problem to make sure you answer the question. So we did answer the question. It's the average acceleration. But the thing is, we need two sig figs, which this isn't. Well, this is, but the units should be in m over s squared. But the thing is, that's not the case. So we need to actually convert this. So what I'm going to do is I'm going to put negative 60 over 1 hour, because that's what it actually is, because negative 60 kilometers over 1 hour, that's all this means. I just put that on the top. And here, 10 seconds, all I did for 10 seconds is just put it over 1. So then you can see that it's a fraction over a fraction. If you have a fraction divided by a fraction, you can flip it and then multiply. This makes it easier. So all I did was just put 10 seconds over 1, and then negative 60, it's already the conversion, negative 60 kilometers over 1 hour. So all I did was just flip it, and then now you can multiply this across. So you get negative 60 kilometers, just multiply straight across, and you get 10 hours times seconds. But still, in the actual question, they want meters over s squared. So we have to find a way to make it that. So what we have is negative 60 kilometers over 10 times hours times s. So the first thing we can try is just simplifying this. So negative 60 divided by 10 will just be negative 6. Now since this is simplified, we can try from the top, we can try to get rid of the kilometers and make it meters. So we have negative 6 kilometers. I'm just going to do dimensional analysis. And all that means is that I'm going to have the initial one, which I just put here, and the diagonals will cancel. So right here, you have negative 6 kilometers. Here, you have kilometers. So if the diagonals match, then they cancel. Once they cancel, you're just left with you just multiply straight across for both the top and the bottom, and it includes the units too. So what you'll get is negative 6,000 meters, because that's the only unit left, and 1 times hour times seconds. So now we have meters over hour times seconds, but we still need meters over s squared, and that's not the case. So now we need to get rid of that hour. So what you can do is you can have, I just brought this down here and did dimensional analysis again. And once again, the diagonals, if they match, then you can cancel them. I'm sorry, those don't cancel. Here, what I did was I put hours, right? And the thing is, if you're multiplying units, it can still work. You can still just, as long as one of them matches, you can cancel them. So here, hours times seconds, so hours and hours cancel. And here, minutes and minutes cancel. So the diagonals units match, so they can cancel. And all I did here was I said that 1 hour is equal to 60 minutes, right? And then 1 minute is equal to 60 seconds. 1 hour equals 60 minutes, 1 minute equals 60 seconds. That's all I did. And then now you can multiply straight across from the top and the bottom. You'll get negative 6,000 meters because there's no other units. And on the bottom, multiply straight across, you'll get 3,600. And then see, there's actually 2 units left. There's an S and an S here, so you multiply those, and you'll get S squared. Now, you just simplify that. You simplify negative 6,000 over 3,600, and you get negative 1.66 m over S squared. Now we go back to the problem, and we actually do have the correct units. So we go back, and we did solve for acceleration, so that's correct. But the thing is, they want 2 sig figs, but we did get the m over S squared. Final thing is, we have to get those 2 sig figs. And here, right now it's 3 sig figs. So we just round it up, and we get negative 1.7. We have the correct units. We solved for the right thing, and that will be your final answer. I hope that helped, and thanks for watching.